We'll now be looking at adding more generalized controls in Apex. Apex is currently very limited in terms of controls. It is also extremely limited in terms of access to controls and the ability to manipulate information within the rig. The main control option that we currently have is called the abstract control. This control has two main uses. It is reasonably straightforward to set up, and it does have quite a number of limitations, although at the moment we'll mainly be looking at its usages. For this, I'll only be working in the manual graph, so I'll go to my basic graph and we'll look at the setup, and here we can add our control, and the control will be listed under Abstract Control. As I stated earlier, this can be used in two ways. The first usage is the more interesting of these, and that is because this is reasonably unique. This control can be used as an independent pivot for any other joint, so I'll rename this control to Pivot. This control can then be connected to any joint within our hierarchy. Essentially, we'll position this control with a transform object, and we'll set the transform of this node using the transform output from the transform object. I can now go to my animation node, and we can activate this. We attached our abstract control to the final joint, and we'll now see that we have a control attached to this joint. The way this will now work is we need to select two joints. First, we want to select the joint that we're going to transform, and after that, we'll select the abstract control. To select this, we'll need to hold Shift while selecting. Once they are both selected, we'll be able to transform our control, and the rotation will be based off the pivot and not off the joint. This will give you different effects based off different key combinations. You can press Ctrl Shift in the viewport to use the abstract control as an absolute pivot, although I'm not actually doing that here. That is something we can look at when covering IK. As I said, this is not a very good display for how this works, or for the benefits which we can get off this. That will be better seen within the context of actual limbs. But this is a very interesting setup, as this allows you to do something very difficult with relative ease. We can now look at the second use for this node, so I'll get a new abstract control node. This will purely act as a control that will have a set position and will be used to drive our parameters. It may be tempting to try and set this control manually. We could attempt to position this control using this matrix, but that will not actually work. The control may actually still show up at the center of the world, but we will not be able to manipulate it. This needs to be connected to a transform object, and it must inherit that transform from the transform object, and the transform object must have one of its inputs driven by an input port. In this case, I'm going to set this from one of my existing joints, and I'm going to set it from the second joint because I've already attached the control to the third joint. So now, if we activate the animation, the control should show up at the second joint. This control can now be used as an item in the viewport to drive values. To do this, I can get a deformation to add to our skeleton. It does not really matter what type of deformation we use, but for something that is easily visible, I'm going to use a peak node, and I'm going to deform this mesh along its normals. So we'll be updating our mesh, so I'll connect this to our base.shape network, and in this case I'll pass the output into my bone deformation. So this deformation will occur before my weights. This could of course be connected after the weights as well, which would give a slightly different result. I'm now going to use the abstract node to drive our mesh value. The abstract node has two screen space transforms, an X value and a Y value. We can use either of these to drive our deformation, and the value that I'm going to be driving will be the distance. So I'll get my X value and I'll drive the distance input. Of course, this will do nothing because this is not currently updating anything. I'll need to connect this to our input to allow us to drive the values. And because I'm using the X option to drive the output, I'll use this to drive the input as well. We can now look at the animation. I'll reset all of the animation. We should now have an extra control placed at our second joint. The abstract control now has a different shape, and we can now click on this, and then we can drag the cursor in the viewport to drive our control. So in terms of functionality, the control is screen space control. It is also possible to drive this control with parameters. If we look at the hints, we'll see that we have an option for channels. We would access this with the shortcut G. This will allow us to set this through a slider, although there are some caveats for this, which we will discuss a little bit later. Currently, this is the main way of controlling our rig through the viewport. It is very limited, but it does give us a basic viewport control. So now we've created an abstract control, and this control will allow us to change the value, and this is reasonably arbitrary. In practice, we want to be able to control this a little bit more finely. With certain controls, we want to be able to limit the values. For example, if we were using this to control a blend, the blend would almost always be between 0 and 1, and we would want to be able to restrict this between those values. To do this, we'll be working with attributes, so we'll simplify this name in order to make it easier to work with, and in this case, this node will be called AC. To update our controls, I need to create a dictionary. This is something I would usually do via scripting, but to make this a little bit easier for people who do not do scripting, I'll create the dictionary with the attribute adjust node. So we're going to create our dictionary. We could rename the key for this dictionary. For example, I could call it dict, but in this case, the final parameters will actually go under the dictionary name of palm, although this will be a key in a greater dictionary. This dictionary will have 3 keys. This is using very specific names, and these names must be exact. The first key here will be lock range. This is essentially a switch, and this will determine whether we lock in the range or not. This will be an integer value, and this will be a value which is either 0 or 1, and 1 will activate this. And if this is 1, we'll have a locked range. The second key will be xmin. This will be our minimum range. This will be a float value, and in this case, I'm going to set this to have a value of 0. The second key will be xmax, and this will be our maximum for the range. This will also be a float, and in this case, I'm going to set this to be 1. So these are the parameters we'll need to lock our range between 0 and 1. We can now look at the dictionary we've created. This dictionary is stored in an attribute called palms. We can inspect this, and we'll see the dictionary entries are lock range, xmax, and xmin. This dictionary is not actually going to be stored in this attribute though. We need to store it in another attribute entirely. So I'll get another attribute adjust dictionary node, and I can rename this dictionary. I'll give this the temporary name of dict. This dictionary can then be connected after my initial dictionary, and I want to make my initial dictionary part of this dictionary. To do this, I'll activate import attributes, and this will import my previous palms attribute as part of a dictionary, and it'll use the name palms as the key of the dictionary, and the dictionary that palms was specifying will be the value for that dictionary. So now we can look at our dictionary. The attribute name should be called dictionary, and it should have a key palm, and this should store a dictionary beneath it. We can inspect this as well, and we should now see our nested dictionary. And I'll actually want to do this 3 times. The second dictionary should not actually be called dict. In this case, we need to identify that this is a control. And this control will have parameters, and then we're defining the parameters. So to identify that this is a control, the palms dictionary will fall under a controls dictionary. The controls dictionary will then fall under an attribute which will be called properties. When we've created the properties attribute, the controls dictionary will be imported into this. So we should now have an attribute called properties. This should contain a dictionary called controls. The controls should contain a dictionary called palms. And the keys for palms should be lock range, xmax, and xmin. So we now have this dictionary. I've made a minor mistake here. This should be control and not controls. There are other values which we can store in this dictionary. For example, we can store the joint color. However, that is not relevant for the moment. We should now be able to add this to our rig, and there are a number of ways in which we can approach this. We could technically add this directly to our graph. We do, however, have one problem, in that this should not be a detail attribute. Instead, this needs to be a point attribute, and it needs to be a point attribute for the point which contains our abstract control. So in this final attribute adjust dictionary node, I can set this to be a point attribute. However, doing this will merely break our dictionary. For this to work, we need to update every node which we're using to create a dictionary, and all of these should be creating a point attribute. We should now have this properties attribute added to every single one of our joins. However, this is not actually what we want to do. We want to only add this to our AC point. To do this, I'll set the group to @name is equal to AC. So this is one way of creating our dictionary, where we create everything and we only link it to the name. There are some dangers of what I'm currently doing. The main one of these is that we can actually overwrite property values that are not specifically set on our points. So we should actually specify the group to be @name is equal to *AC for every single node in the network where we're creating it. This should technically be working correctly, but it does open up potential issues. It's a reasonably dangerous way of doing this, and it's not particularly flexible, as we will have to update group names on multiple nodes. A better way to approach adding this dictionary to the points would be to use an attribute wrangle node. I'll connect this directly after my graph, and I'll pass my dictionary into the second input. I'll then return all of these dictionaries to creating a detailed dictionary again. I can then remove the groups because we do not need them when creating a detail attribute. I'll now use the attribute wrangle node to add this detail attribute to our geometry. This attribute is going to be a properties attribute, so I'll specify this as a dictionary with d at properties. This will give us a properties dictionary, which is attached to our points. I'll set this with my detail attribute using the detail function. We'll get this from our second input, so this will be input 1. The attribute name will be properties. And the third value will be 0. If we have done this correctly, we should once again have the properties dictionary attached to our points, but once again this will be attached to all of the points. On the attribute wrangle node, I can then specify a group, and this will be @name is equal to AC, which will once again apply this to only this joint. However, in this case, we only ever need to specify this once, as there's no ambiguity as to what will be happening. As I've stated previously, there are numerous ways of doing this. We could also do this from within the edit graph node, but this is probably one of the more straightforward to explain. And this is one of the ways where I can build this using only SOP nodes. So we should now have a properties attribute, and this should contain our controls dictionary. We can now test this. I'll reset my animation node, and we should now have our values limited between 0 and 1. However, one thing we should note is that this will only currently work properly when we're manipulating the control within the viewport. If I was to select the control and then press G to get the channels, we would now be able to set this manually. However, doing this will allow us to exceed the values which we have just limited this to, as this value here will not be clamped. So currently using the channels in this way can actually break our control entirely, so you'll need to be careful of that. So this is how we get a control within the viewport, and this is how we limit that control to a range. In this case, we would be limiting the control between 0 and 1. There are other methods of creating controls within the viewport, which are also rather limited at the moment, but we'll look at those at a later stage. At the moment, we've covered all the core features of Apex. Next, I'll start looking at some basic solvers.